hope all of you are really working very hard for your upcoming CSIR NET as well as the GATE examinations. Welcome to the India's largest learning platform, Unacademy, India's best platform for the preparation for CSIR NET as well as the GATE examinations. Myself, educator Kripasindhu Karmakar, I have qualified the CSIR NET exam with All India rank 2. I have qualified the GATE examination with All India rank 32 in the GATE examinations. I am having a lot of experience to teach all of you. So it will be a great journey if you study from the Unacademy and Unacademy Plus. In the Unacademy Plus, I teach the complete organic chemistry and the physical chemistry in the exam-oriented approach, and some of the important topic from the physical topic, some of the important topic from the inorganic part also. We do a lot of practice course. So if you're new to this particular YouTube channel, then do not forget to subscribe the channel and do not forget to share and like the class if you like it. Okay. So today's class is going to be very important, because in the today's class I will be discussing about the most important questions of the organic chemistry, as you know. So we have targeted the 500 important questions from the organic chemistry, and this is the fourth class of in this month. Let's see how many classes we have already completed. So we have already taken these classes. This one is the first question. Next one we have done this. After that we have done this. And the next one. See, all of the questions are the very important for your upcoming examinations. I hope I am audible to all of you. Am I audible and visible properly? Please tell me, everyone. Is that everything going fine? Now this is the very important question. Okay. Whatever the question I am saying that important, just mark that as important, because there is a very high possibility to be asked into the CSIR NET examination directly. Okay. It's a very important question. Next one is also important question. This one is also. Then Bialysin-Mann reaction. Then the cis-Jasmine formation. This is the question from the pericyclic reaction. I have told you the shortcut. This one is an example for the 3,3 sigma-tropic rearrangement, and after that enamine cyclization formation of through the formation of the enamine, through the formation of the iminium ion. Cyclization through the formation of the iminium ion. This one. Cyclization through the formation of cyclization through the formation of the iminium ion. Through the formation of iminium ion formations through cyclization, right? Now next, let's do this reaction. So this reaction is also an example of a molecule like this. So here we are having the epoxide group in one of the plate, and after that attack of the nucleophile takes place. Then this one is the reaction from the pericyclic reactions, dihydroxylations. This one is the Joule-olefination reactions. So as I have already told you that in the scenario Joule-olefination reactions, it is mandatory to do the alkane. It will not be the case for the Peterson olefination or the Corey-Winter olefination. In the Corey-Winter olefination, the C or Z, E or Z both can form. Okay. In the Corey-Winter olefination, Z or E both are possible. In the Peterson olefination reactions, both is possible. Either Z or E, both are possible. But it is only the one reaction, the Joule-olefination reactions, in which the E alkene is only forming. Okay. And you have to remember, because exam may not directly ask a question. In this particular scenario, the leaving group and the nucleophile both are presenting into the same molecules. So this is an example for intramolecular Joule-olefination reactions, in which both the nucleophile as well as the leaving group, they are presenting into the same molecules, right? So finally the product that will be forming is an E. Okay, so in the previous class I have given you some of the homework. So I hope all of you have done this homework. Now let's see the solution of this question. Solution. So first thing first, kya hoga? There will be the formation of the ANME2, and here is a phenyl group is there, and both are having the opposite stereochemistry, right? So अब देखो, in this particular scenario, here is also methyl group, here is also methyl group, positive charge, and here is a O minus. Now, in this particular molecule, there are the two possibilities. One is the abstraction of this proton. You know, this will be the example for the pyrolytic scene elimination. This one is an example for the pyrolytic scene elimination reactions. Now, for this pyrolytic scene elimination reaction, please tell me from which of the proton this will be abstracted. Is A or is B? कौन सा proton abstract होगा? Which of the proton will be abstracted in this particular reaction mechanism? So basically you have to see the stability of the negative charge. तो आप बताओ in which of the carbon stability of the negative charge is more? In this particular scenario, in which of the side the stability of the negative charge is more, A or B? Why you are saying B? देखो, you have to see the stability of the negative charge. Now, stability of negative charge. So if I talk about the stability of the negative charge, then there are the two possibilities. Either negative charge can form over here and either it can form over here. Now you know that if the negative charge is forming into this position, then there will be the formation of the negative charge which will be adjacent to this group. And you know this is stable because this negative charge is stable because this negative charge is stable through delocalization. So a negative charge जो है ना, ये delocalization के through delocalization with this with benzene इनल ग्रुप के साथ delocalization में take part कर रहे हैं. So that's why this group will be forming, right? So finally, ultimately, what will be the reaction that will be taking place? In positive, and here is the OH. In the next, this will be formation double bond, and this group will be eliminated. So finally, in this particular scenario, you will be getting a conjugated alkene will be forming, right? In which this phenyl group is adjacent to this directly double bond के साथ adjacent होगा. Now let's do the next question. So in the next question, the stereochemistry of the NME2 and both of the phenyl groups, and here the phenyl group is also above the plane. Okay, here the phenyl group is also above the plane. So whenever you are taking the molecule with the H2O2 hydrogen peroxide, तो क्या होगा? Then in that particular scenario, nitrogen, there is a two methyl groups. Nitrogen will be having the positive charge, this will be having the O negative. Now आप देखो, this recursive proton from the scene, इसका scene above the plane का scene क्या होता है above the plane? So this must be abstracting the proton from the above the plane, but here in this particular molecule hydrogen is below the plane, so this proton can't be abstracted. एक proton abstract नहीं हो सकता है. Why this proton cannot be abstracted? This proton cannot be abstracted because they are present into the different planes, right? So but for this molecule you are having HA and HB. But which proton will be abstracted for this? So obviously the same proton. Now we can write down the molecule like this. हम लोग इसी तरीके से लिख सकते हैं ना. Nitrogen two methyl groups are there. Nitrogen will be containing the positive charge. Here is the O negative, right? And here is a proton. So now O negative is attacking to this proton. This will be formation double bond, and then the positive charge of this group will be neutralized. So finally क्या होगा? This will be the double bond formation will be taking place. Okay, great. Now in the previous examples, I have given you the another homework also. So all of you have done this. So we have to apply this particular part step by step, right? So question number 3. So in C5H11, here is the CHO, and now this molecule will be treated with the OTiCl3, and oxygen will be having the positive charge, right? And this molecule is a COPH, sorry, CO2Me, and selenium phenyl, and this molecule is treated with the isopropylamine. So isopropylamine will be isopropylamine will be acting as a base, and it abstracts the more acidic proton. So more acidic proton will be always adjacent to the electron withdrawing group. Since you know this one is an example for the electron withdrawing group, so finally this group is formed. Then this negative charge will be attacking to this, and positive charge of the oxygen is neutralized. So this one will be the O, TiCl3, and here is the CO2Me, and here is selenium. Okay, are you clear? Are you understanding? Okay. Now we are having this group, and after this part we are treating this molecule with the. Now let's work up this. So if you work up is the step in which the final product will be no negative or positive charge, right? In the next step, we are using acetyl chloride, MsCl, acetyl chloride, pyridine, and the CH2Cl2 salt. So क्या होगा देखो, this one will be having ANC5H11, and here is the OTS, OMS will be there, mesitylate, and here is the CO2Me, and here is the selenium phenyl group, right? So now what will be the next step? Now in this particular next step, how the reactions will be taking place. Dekho. This one is also an example for a scene elimination reactions. Dekho. How this will be taking place. Selenium is having the lone pair of electron, and this is attaching to this group, and this group will be eliminated. So finally there will be the formation of the selenium formation takes place over here. There is a selenium formation takes place over here. Now since selenium has donated the electron, so selenium will be having the positive charge, right? And write down the two substituents. One is the normal C5H11, and one substituent is the CO2Me. Right. Great. So now in the next step, how the reaction will be taking place? So we will be neutralizing the positive charge of the selenium, which will be giving to the formation of the positive charge generation takes place over here. And the next step, this will be formation of the double bond. So finally, we will be obtaining this product. See the stereochemistry, like since we are not showing any stereochemistry, so this group also can form. At the same time, this group also can form. But if the stereochemistry is clear, in that particular scenario, you have to give the correct answer. Okay. In that scenario, you have to give. OMS is an example for a good linear. Yes, Moni. You are correct. Chalo, done. Now let's draw the mechanism of the next part. Next part is having a question like this. OH, and here is also OH, and we are having the substituents of this R group. Let's take this R group. Okay. So now Cl, C double bond A, Cl. This one is forming A. Now in the next, we are treating this molecule with the nitrogen. Here is the phosphorus. Here is the phenyl group. Here is the methyl. Here is the methyl and the feed. Then it is forming the B. So, what is the name of this reaction? What is the name of the reaction? इस reactions का नाम क्या है? Let's write down the full molecule. Actually, then only you will be getting the feeling of this reaction. Very good. So this example of a reaction is called the Kure-Winter olefination reaction. Kure-Winter olefination reaction. तो देखो, for this particular scenarios क्या होगा? For this molecule will also attacking to this carbon position. This goes up, comes down, and the elimination of the one same group takes place. At the same time, this hydroxy group also attacking to this, and it is eliminating the another part, right? It is eliminating the another part. There if the stereochemistry of the hydrogen is above, that means whole of the molecule is present above or below. If the stereochemistry of the one center has been given, so another center must be present above or below. This is a very important scenario, right? So each and everything molecule will be remaining same because there is no reaction is going to happen. This is the CO2Me, but this molecule will be presenting into below because the hydrogen gas stereochemistry also into the. So finally, just try to understand everyone. This one will be following the group like this sulfur. There is also oxygen. Now let's do the next one. So this one will be having the 2 methyl groups. This one will be having the C2Me. This one is below the plane, and this one will be having the oxygen, and here is a group. So with it we are attending the molecules in such a way that here is a phenyl group, phosphorus. Now my question is to all of you, in this particular scenario, you are understanding this will be acting as a electrophile because of the charge. Now here आप nitrogen or phosphorus, which will be acting as a nucleophile because both of the molecules are having the lone pair of electrons. दोनों के पास nitrogen का lone pair of electron, right? Now if you want to know in which group this belongs, nitrogen, phosphorus, arsenic, antimony, right? So the same group it is belonging. If you talk about the electronegativity, if you keep on increasing from lower to upper, then it will be electronegativity will be increasing, right? Electronegativity normally increases. Electronegativity normally increases, right? So nitrogen is more electronegative than phosphorus. So if you take care of this scenario, then about the phosphorus or nitrogen, which will be acting as a nucleophile. Please like the video if you like the class, and do not forget to subscribe to this channel. So in this case, phosphorus will be attacking as a nucleophile. Now phosphorus कहाँ पे अटैक करेगा, सल्फर पे या कार्बन पे? Now in this scenario, phosphorus will be attacking the sulfur or carbon. Whenever you'll be unable to understand, then just do both of the things, right? Like the path A or path B. Then just see the stability of the product. After that time, then you'll be deciding. In this scenario, you have to decide in between which of this particular product will be going to most stable. Okay. In this way, you have to decide. So for this particular scenario, phosphorus will be attacking in such a way that phosphorus oxygen bond is very stable, and a phosphorus oxygen double bond is stable. And sulfur is also depending upon the same group: oxygen, sulfur, selenium, tellurium, polonium, right? So phosphorus also makes the strong bond with the sulfur also. And the main important matter of this phosphorus sulfur bond is the 3p3p overlap, right? Phosphorus is also having the outermost low lying vacant 3p orbital. This is also 3p orbital. So 3p3p overlap is more energetically favorable, right? Overlap is more energetically favorable than the phosphorus carbon. Carbon is having the 2p and phosphorus is having the 3p. So there is no significant overlap takes place over here. That is the reason because of which phosphorus is attacking to this molecule, and there is a negative charge formation takes place over here. So finally क्या होगा देखो, oxygen, and here is also oxygen, and after that here is a phosphorus. There is a new bond formation takes place between the sulfur and phosphorus. Now it is having negative charge. Since phosphorus has donated the electron, so phosphorus will be getting the positive charge. Since phosphorus has donated the electron, so phosphorus will be having the positive charge. Nitrogen is not having. Now just try to understand everyone in the next part. क्या होगा? Next part में this will be forming the double bond, and if this forms the double bond, then automatically we'll be getting the same product again. It will come into the reactant. But have you seen any reactions in which the reactant starting material is coming back? Since you have to do the reaction, so obviously you have to do something new. इसलिए ना, these reactions will not be take place. This negative charge will not attach to the form again. Same form करने के लिए attach नहीं करेगा. So then this carbon sulfur bond will be broken. Now why the carbon sulfur bond will be broken? The carbon sulfur bond is broken so that the phosphorus double bond oxygen, phosphorus double bond sulfur can form. So in this particular scenario, there will be the generation of the carbon takes place. Yes, Amit, how are you? So finally, क्या होगा? This one is having the two methyl groups. Yes. And here is the CO2 image. CO2 image present above. Now in the next step क्या होगा? Oxygen is containing the lone pair of electron, and this one is the carbon generation takes place, right? Oxygen is having the lone pair of electron, and here is the generation of the carbon takes place. Whenever a negative charge से अगर कोई मान लो, here is the carbon. This is called carbon, and this is called the lone pair of electron. So carbon is an example for electron deficient species. Always remember, carbon is an example for the electron deficient species. And whenever you are taking the lone pair is already electron species. So there is always a transfer of electron takes place from the lone pair of oxygen to the carbon. Okay. Now let's do the next example. Just make sure that you are writing this example. Okay. Example लिख के रखो everyone. So oxygen. Here is also oxygen takes place. Here is the carbon. Okay. So after this formation of the carbon, since this oxygen has donated the electron, so oxygen will be having the positive charge. Carbon has accepted the electron, so it will be having the negative charge, right? Now there are the two methyl groups are present, and for this molecule there are the cyclopropane ring, and here is the CO2 imine. And the stereochemistry of the CO2 imine has been shown into above. Okay. Then what will be the next? In the next, positive charge is there on the electronegative element, so that is not going to be stable. You know, the positive charge on the electronegative element is not going to be stable. So this will be neutralizing the positive charge. If this neutralizes the positive charge, which charge will be obtained over here? इसमें कौन सा charge आएगा? Are you having any idea? Then what is the things that you need to do? इसके बाद क्या करना पड़ेगा? Very good. So now here there will be the positive charge generation takes place over here, right? Now after that, this negative charge will be forming the double bond, and it will be stabilizing the positive charge. So finally, the group that will be obtained is like this, and the stereochemistry of this molecule will be like this. So this group is actually present above below the plane. Okay? This molecule is present into the below the plane, and this group is present into above the plane. And this is the final molecule takes place from here. Okay, this is the final molecule takes place. Are you getting this? Exactly. So for these reactions, the elimination of the carbon dioxide takes place. Now let's do the next examples. And all of you solve this question first, and then just give the correct answer. Okay. Question. So what will be the correct answer for this question number? This is a question from the Diels-Alder reactions, and I'm giving you a hint. This one is a question from the Diels-Alder reactions, and this one is a question from the 1,3 dipolar addition reactions, right? So I think by this hint will help you for finding out the answer of this question. Okay, so great. So let's start this question and give the correct answer of this question. This is a question directly taken from the Carruthers book, and Carruthers में जो previous में question है ना, उसके पास है ये सारे के सारे कुछ. So let's take these examples. Page number 206, page number 266, 266 का 9. So here there is only one. In this scenario, there is only one benzene. Now benzaldehyde. Now it has become the AN. There is a TS. There is a group class. This is treated with the group Me. And there is NH, CH2, CO2H. Now we have been given this heat, the triethylamine and the dimethyl formamide solvent. Okay, and you are forming the dimethyl formamide DMU. Finally, you are getting the product. So you have to say what is the product that will be formed over. इसमें कौन सा product होगा? So take 5 minutes time, everyone. Try to solve this question and give the answer. Okay. Take the 5-minute time for this question. Try to solve and give the correct answer for this question. Okay, solo picking it. Okay, so if you try this particular question, then you will understand देखो क्या हो रहा है. In this particular scenario, this one is an example for a 1-3 dipolar addition, but obviously for that you have to understand ना किस तरीके से कर रहे हैं, like how this will be possible and how we are doing this. This is also very important part, right? देखो, so how we are doing this reaction, let's see how we are doing this reaction. Okay? Okay, so first thing, here is the formation of the iminium ion takes place. Since you know one is oxygen is there and one is the proton is there, so whenever a secondary amine, whenever a secondary amine reacts with the carbonyl, this forms the iminium ion. Iminium ion means C double bond N, and nitrogen will be having the 4 substituents with its positive charge. Okay, so this is called the iminium ion formation. So for this example also, after the elimination of the OH, benzene will be remaining as it is. Here is the ANTS fossil group will be there, and here is the group is like this. Now finally, this will be having the nitrogen, and here is a methyl. Here is the positive charge. Okay. And this center will be undergoing the reactions of the C4. Now, up देखो, this one is the electrophilic position because this one requires the electrophilicity, okay? And it is the internal nucleophile. So internal nucleophile will be attacking to this in such a way that the positive charge of the nitrogen will be eliminated. So finally, the cyclization will be taking place. So finally, in this scenario, क्या होगा? Cyclization will take place. So finally क्या होगा? So this will be remaining as it is, this center. Now this will be the nitrogen. Here is C double bond oxygen. Here is oxygen, and there is a new bond formation takes place over here, and here is the methyl. Right? So are you understanding this part? Now in the next step, just try to understand everyone. Nitrogen is having the lone pair of electron. Now in this scenario, the nitrogen is having the lone pair of electron. तो क्या होगा देखो, nitrogen lone pair of electron will be forming the double bond over here. This will be forming the bond, and here is a negative charge formation takes place over here. So finally, this will be leading to the molecule like this. Benzene ring will be remaining as it is, and here this group will be the nitrogen, and here is a negative charge, and here is a methyl group. Now nitrogen will be having the positive charge over here, okay? And here is a part nitrogen, here is a TS. So now this negative charge will be attacking to this molecule. This is attacking to this, and positive charge of the nitrogen is being neutralized. So finally, how many member ring will be forming? So finally, you will be forming 1, 2, 3, 4, 5. So finally, you will be forming the 5 member ring, right? In which 1, 2, 3, 4, 5, 6. So it's already 6 membered. So finally, the molecule that will be obtaining, this benzene ring will be remaining here, right? This is the nitrogen. This is the tosyl group. 6 membered ring over here. Here is the 5 membered ring will be there. So nitrogen methyl, and here is a negative charge, okay? And this molecule is there is a new bond formation takes place. So finally, you are understanding that this group will be obtaining over here. Now the next, let's do another example. Now let's do the another questions. Try everyone this question. Okay, these questions are very important. Whatever the question that I am doing, all of the questions are very important. for your upcoming examinations. एग्जाम में डायरेक्टली आ जाएगा क्वेश्चन इस तरीके से. So you have to take care of these things very much rigorously. Okay, great. Now let's do the next example in which I will be treating this molecule with a group, and after that you have to tell me how the reactions will be possible, right? So, great. Group, okay. So here is a nitrogen minus and here is a NHTS. So basically in this particular scenario, I hope you are understanding. Here is a negative charge is already there, right? Negative charge is already there, and here is a butyl group. So what will be the next examples and how the what will be the final reaction of this step? इसका final reaction mechanism क्या होगा? What will be the final reactions? So in this particular scenario, since you are understanding tosyl group is an example for a good living group, so this group will be eliminated and each and everything will be remaining the same. These hydroxy groups are already protected form. These hydroxy groups are already present into the protected form. So here is the oxygen, here is the bond, it's a butyl, and here is a nitrogen, double bond nitrogen H, right? And the next step क्या होगा? Nitrogen is having the lone pair of electron, which is forming the triple bond. Now this triple bond will be forming the negative charge. You can form the negative charge, and you can, if you want to show directly, then also you can do, right? So we are showing step by step. That's why we are showing. So oxygen, here is also the group is like this, and then the epoxide is there, and here is a negative charge. So negative charge will be forming the bond, and this bond will be broken. So finally, you will be getting the molecules in such a way. This one is oxygen, this one is also oxygen. They are in the protected form. Now the stereochemistry of the hydroxy group is the most important part. So hydroxy group stereochemistry will be below the pen. Okay, and here is there is a allylic hydroxy group will be formed. So now, if I am saying this answer to all of you, and if I treat this molecule with the plus DIPT, if I do the surplus asymmetric epoxidations, in that scenario, that will be above or below? Plus DET or DIPT? So surplus asymmetric epoxidations will be doing the part into another part. Now let's take the another examples. Okay. Now let's take another one. So this one is a cyclohexyl group. Cyclohexyl group, and here is a CHO. Cyclohexane group, and there is a CHO. And now for this molecule, we are having the N isopropyl. Here is a lithium, and this is the. So basically, in this scenario, this is also isopropyl group. This is also isopropyl group. So you have been basically taking the molecules of LD. LD लिया ना तुमने यहाँ पे. अब बताओ, in this scenario, which of the reactions will be taking place? If the only LD has been taken and only LD and the other work, क्या करेगा बताओ? That will be the final product that will be taking place. So it will be forming this product, or this will be forming the group like this. This one, or option C, or option C. This one will be the OLI, and option D will be this one. Okay. What is the correct answer of this question? A, B, C or D? So if you're watching this class and if you like, then do not forget to like. Very good, Monica. So most of the students might be giving the answer like the B or A, but we are it's not the correct answer. The correct answer of this particular question is going to be the correct answer will be the D. Why that is so? So whenever you are having a particular group and there is only one base, so you might be thinking that sir LDO the acid base reaction करता है. Yes, acid base reaction करता है. But whenever you will be giving the electrophile, then only it will be undergoing as a acid base reaction, right? Suppose this is a reactant, and if the product is also same, then what is the use of this reaction? We have not done anything. If this is the product, then we have not done anything. So that will not be there, right? So now for this particular group, because of the aldehyde is very much, because you know aldehyde is a very much electrophilic in nature, and for this particular group, the group is having the group like this lithium. It will be forming a 6-member cyclic transition state. क्या बनेगा ये? This will be forming the 6-member cyclic transition state for the molecule like this isopropyl group. This one is also having the isopropyl group, but this one is having the hydrogen. Isopropyl में एक hydrogen होता है ना? Now after that, this oxygen will be attacking to this lithium. This will be formation of the double bond. And now this hydrogen will be acting as a hydride, and now the hydrate transfer takes place over here. Okay. इसके बाद hydrate transfer होगा. So finally क्या होगा? In this scenario, this will be leading to the OLI. And here is the hydrogen. So finally, if you work up this molecule, if you work up, अगर work up करोगे तो finally क्या बनेगा? So this hydrogen and here is the hydrogen. So in this scenario, the reduction of the aldehyde takes place. Reduction of the aldehyde. Reduction of the aldehyde takes place. So reduction of the aldehyde takes place if you directly give the LDA for this molecule. Okay, are you understanding this part? So depending upon the scenarios, you have to take the decisions that which one will be the product. Okay, great. Now let's do the another example. So basically, this will be the question answer session, right? So whenever we'll be giving a new questions, you have to try to solve that question and you have to give the correct answer for that question directly. Okay, great. Now let's start the another questions and let's see how many of you will be able to do this question. So great. अब बताओ. So for this molecule, there is a product. Four-membered and five-membered ring. This should be cis-fused or the trans-fused. देखो, one is four-membered ring, one is a five-membered ring. So the ring is small, right? If the ring are small, then obviously you have to give the priority to the cis-fused. Cis-fused will be the more stable. Right? Methyl and the hydrogens. Now with this particular group, this one is the methyl above the plane. And below the plane is the hydroxy group. Now there is a double bond is remaining, and here is a methyl also. देखो, what is the shortcut for the normal hydrolysis, the normal ozonolysis? So in the ozonolysis, just add one side oxygen and another side oxygen. So finally, you will be getting the carbon in this side, and this side also will be getting carbon. So this is the shortcut. But the same thing will not be applied whenever you will be taking the allylic hydroxy group. देखो इस क्वेश्चन को देख के समझ में आ रहा है ना? This one is an example for allylic hydroxy group. This one is an example for the allylic hydroxy group. So allylic hydroxy group के केस में थोड़ा सा different होता है. So after that, just do the ozonolysis. Then tell me everyone which is the product will be obtained. कौन सा product होगा with the mechanism. So we'll be discussing this one. This one is also very very important. मैं जो 4 क्लासेस में कराया ना, तो इनमें से बहुत सारे क्वेश्चन आ जाए. If you are not present in the Telegram channel, then just click on this link of this Telegram channel t.me/unacademy _class _preparation. Download the Unacademy learning app and use this Telegram channel. There you'll be getting all of the PDFs. There you'll be getting all of the PDF and all of the things. Yes. So hello everyone. I hope all of you are really working very very hard for your upcoming CSIR NET as well as the GATE examination. My name is Kripasindhu Karmakar. I have qualified the CSIR NET examination with All India Rank 2. I have qualified the GATE examination with All India Rank 32. I have the teaching experience of the 2 years. So now you can be getting the opportunity for asking a doubt. There is a new feature has been introduced to the Unacademy. You can ask your doubt to the doubt clearing educator directly. So these are the steps that in which if you follow, then you'll be getting the opportunity for asking your doubt to the educator directly. Okay. So you have to follow this step for going into these steps. So at first you have to go to download the Unacademy learning app if you have not downloaded yet. If there is any code is asking, then use the code CRIPLIVE. Downloading the app is free, and you can buy the special classes also for the free. Use code the CRIPLIVE. Then you just go to the doubt and solutions features on your home screen. Then question then 2. Click on ask a doubt and upload your doubt image. Step number 3. Crop the image and highlight the question. Step number 4. Choose the subject that the question falls under, and you'll be getting the detailed video solutions of that particular part. Okay. Now Unacademy goal. So achieve your CSIR UGC NET goal with the 20% off on all of your plus subscription. So on all of your plus subscription as well as the iconic subscription. This offer was valid till 28, but this has been extended, and this is valid till the 30th of April. इस महीने का end तक ये valid है. Okay. So do not forget to take this great golden opportunity by using the code CRIPLIVE. Use code CRIPLIVE, then you'll be getting the 20% discount. So 20% discount is one of the most highest discount ever of the Unacademy. 20% discount बहुत ज़्यादा होता है ना. So take the 20% discount. Use my code CRIPLIVE code for getting the 20% discount. And this is the limited time offer. I think now that will not be extended. Now the offer will be not more extended because it is already extended till the 30th April. 30th April तक already extended हो चुका है. If you have any problem or any doubt or any query related to this, just call in this number 8585858585. So there is a 5 times 85. 5 times 85 is the official number of Unacademy. So 5 times 85 will be called. Then one representative will be calling with you. Okay. The Unacademy goal. These are the current pricing. These are the regular price. If you use the CRIPLIVE code, then you'll be getting the 20% discount. And this is the price after the 20% discount. 20% discount के बाद ये price है. Okay. So for the 12-month subscription, you have to pay 12,760 rupees. For the 6 month, 10,208 rupees. For the 3 month, it is a 5,500 rupees. You'll be getting a lot of discount over here. Okay. After getting the discount, this is the price. And for the iconic subscription, you'll be getting the externally study material. You'll be getting one of the educator will be taking care of all of your progress in your journey of CSIR NET preparation. Okay. And he'll be giving you the guidance and the hints and how your progress is. He will monitor actually. He or she will monitor your all of the journey. So now these are the recent pricing. Now you'll be getting the 20% off by using the code CRIPLIVE. Use code CRIPLIVE for getting the 20% off. 20% discount on your Unacademy platform. So on your plus and iconic subscription. So these are the scenarios we have started a new topic. So let's take this. That's the homework. इसको homework की तरह लो and try to solve this question. So how this mechanism will be taking place? देखो, start to understand everyone. देखो, this will be remaining the same. And here the methyl group will be there. Here the hydroxyl group will be there. Now, whenever you are having the double bond, the intermediate, how to write down the intermediate? Intermediate को किस तरीके से लिखोगे? Just do this. Break the double bond and make a bond like this. Make a 5-membered ring in which add the 3 oxygens. 1 oxygen above and 2 oxygens over here, right? Yeah. So if you write down the molecules like this, then we'll be obtaining that this group will be writing the molecule like this. Oxygen. Now देखो, this bond is weak in nature because oxygen bond is there, ना? The oxygen bond break होगा. This will be forming the double bond. This will be forming the double bond. This will be forming the group. At the same time, this also will be forming the 2 minus. So finally, देखो क्या बनेगा तुम्हें. So hydrogen is above the plane. Methyl is also above the plane. This is a 5-membered ring. Okay. 5-membered ring will not be remaining अभी तक because this bond has been broken, ना? Because this bond has been broken, now the 5-membered ring will not remain. 5-membered ring अभी नहीं रहेगा. Okay. Now this will be the COMe. Now in this step क्या होगा? In this step क्या होगा? There will be the generation of the CO2H. Because we have a C double bond oxygen, and here the hydroxylase group is down. So it is better to write down in this way. C double bond oxygen. So finally in this molecule क्या बनेगा आपको पास? So the stereochemistry of this group is like the CO2H, and this stereo is also CO. Monica was saying, sir, one question of the ozone given in the NET exam are given, and we have to tell the reactant and the correct answer in the official key is the given alkyne. That question might be different. Question अलग हो सकता है ना? शायद अलग दूसरा क्वेश्चन है ना? That might be possible. Is there any doubt? Please let me know. Okay, so thank you so much everyone for attending the sessions. I hope all of you will be working very hard for your upcoming CSIR NET as well as the GATE examinations. Work very hard and you get the JRF. And let's crack it. And do not forget to like, share and subscribe to this YouTube channel. And do not forget to like the video.